This hypothetical developmental network produces spikes in certain cells of the ectoderm of a beetle. However, not all cells in the ectoderm have spikes. Some are smooth. Based off the different symbols between the individual letters that represent genes, we can determine the relationship between each gene in the developmental network. The arrows represent instances where a normal gene product stimulates transcription of the next gene product in the pathway. The T-bars represent instances where a normal gene product will inhibit the action of the next gene product in the pathway. In the original developmental network, the S gene has an arrow leading to the P gene, which means that a normal S gene product will stimulate transcription of a normal P gene product. The P gene has an arrow leading to the I gene, which means that a normal P gene product will stimulate transcription of the I gene product. The I gene has a T-bar leading to the K gene, which means that the normal I gene product will inhibit the action of the K gene product. This is important because the K gene also has a T-bar leading to the E gene, meaning that a normal K gene product will inhibit the action of the E gene product. The E gene is the final gene in the pathway, with an arrow leading to spikes, meaning the E gene product allows for the production of spikes in the ectoderm of the spiny beetle. In other words, if the E gene is inhibited, then the production of spikes will not occur. Next, we will discuss several combinations of mutated genes in the spiny beetles and if these will or will not be able to produce spikes. The first mutant strain is mutated in the P gene, represented in green. In this situation, the P gene product is not able to stimulate transcription of the I gene product. Since the I gene product is necessary to inhibit the action of the K gene product, this will no longer occur and the K gene product will inhibit the action of the E gene product. With the E gene product inhibited, the spikes will not be produced. The second mutant strain is mutated in the I gene. In this situation, the I gene product is not able to inhibit the action of the K gene product. Since the K gene product will not be inhibited, the K gene product will inhibit the action of the E gene product. With the E gene product inhibited, the spikes will not be produced. The third mutant strain is mutated in both the I and E genes. In this situation, the I gene product is not able to inhibit the action of the K gene. Since the K gene is not repressed, it is able to inhibit the action of the E gene even if it wasn't mutated. However, the E gene is also mutant, and because of this it doesn't matter what else is mutated. The spikes will not be produced with the mutated E gene. The fourth and last mutant strain is mutated in the S and K genes. In this situation, the S gene product is not able to stimulate transcription of the P gene product. Without the P gene product, the transcription of the I gene product will also not occur. However, the K gene is also mutated, so it will not be able to repress the E gene product. Therefore, the E gene product will allow for the production of spikes. I hypothesize that the reason not all cells in the ectoderm have spikes is because the beetles acquired somatic mutations throughout their life from environmental factors such as ultraviolet radiation or possibly from errors during replication. This would result in a mutation of the genes in some cells and not others based on exposure and chance, and therefore only some developmental pathways would be affected.